Hey there, I'm Said. If you remember from the last time, we created two blueprints for the right and left hand with nanite mesh and all the necessary settings that we need to use them. But we didn't make any animation for them. In this lecture, we will go through how we can make some animation and then use them with the VR input system. If we open our blueprint, we can see we have the hand skeletal mesh and also a list of nanite objects that we attach to the sockets of this object. We are attaching using the constructor script to connect the nanite meshes, which is not a skeletal mesh anymore, and they are a static mesh to the socket place of our static mesh or skeletal mesh in this case. In order to make animation for it, we created control rig, a system in Unreal Engine that you can create a rig or you can create even inverse kinematic system for your skeletal mesh easily. I already prepared everything for you. If you pull the project from the repository, you can use it. But if you want to know, when you open the control rig for your skeletal mesh, you have the list of the rigs that you already created. If you right click on them, you can create controls from the selected. For example, I created controls for the top parts of each finger, in this case, the red circles that you can see. Then using these controllers that you made, if you click and drag on them, in the scene, you can create an array of this object using create item array. And then if you also click and drag from the corresponding rigs and bring them into the nodes parts of your scene, then you can attach each control rig to the corresponding slot or corresponding rig. In this way, the movement of the controller can also influence the rig itself and at the end the skeletal mesh. I should say that you can also use inverse kinematic that I'm not using here to make it simpler for you, but just feel free if you want to test to use the 3-step or 3-rig inverse kinematic or even 2 rigs inverse kinematic, and it would be very interesting. I already use it in my other projects. Okay, now we have our control rig, and if you click and drag it into your scene, the sequencer will automatically open and it will give you access to your control rig and your skeletal mesh. And we can easily animate our hands, or in this case, our skeletal mesh. However, for these lectures, I made it simpler by only one pose and lerping between the pose. In order to make the animation, just select add a new key in the hierarchy of the sequencer, and if you do not see the controller, just make sure that you are not in the game mode by pressing G on your keyboard. You can always switch between the game mode and normal mode by pressing G, and then using the normal navigation tools like rotation or maybe move or scale. However, scale is not meaningful in case of a skeletal mesh, but just to know, you can modify these controls that you made in the control rig. When you reach to the condition that you like, for example, I'm making an animation for the teleportation. When you press the teleport, I would like to see some kind of animation. And when you make appropriate animation or maybe pose for your hands, in that case, you can save it as animation. Just wait a little bit that I finish with the animation that I like, something like this, that shows, yeah, I would like to go there. And then you can save everything that you made as animation sequence. Yeah, by right click here and bake animation sequence. Give it a name that you can distinguish between these animations and maybe other animations that you have in the scene. I call it pose teleport. You can also make it some small animation as a couple of seconds animation, but it's not necessary in our case, and I just make a pose but save it as animation asset. Perfect. Now you can see we have our animation asset that is the constant pose, but we can use it to blend between different conditions. Now I will also make another animation for the idle stage that when we are not doing anything, we would like to stay at that pose. I can also use the default pose that we extracted from the imported FBX file, but I would like to have another animation or another pose for it. It would be also good to add animation. In this case, it means again couple of seconds of movement of your hand, that when you're in the idle pose, you have also some small animation that gives a better immersive feeling to the user. But again, in this case, I make it simpler with one single pose that I will use. Now, as you can see, I have two conditions, idle and teleport. The next step is going to the animation part and create animation blueprint. The animation blueprint gives us access to our animation assets that we create, and we can do many things like blending between them or creating more complicated conditions and then controlling them using the blueprints. In the animation blueprint, you have the output pose that is always the things that is the latest stage that you would like to present. It means after blending everything or modifying anything, at the end you should connect it to the output pose, and it will show the final result to you. I would like to lerp between the idle condition and teleport condition. It means when my input, for example, alpha value is 0, I would like to be in the idle stage, and when the alpha value or input is 1, I would like to go to the next stage that in our case is a teleport. In order to do this, first let's test it. As you can see, by entering the value for alpha, we can lerp between these two conditions or blend between these two conditions. But in order to be able to modify it in the blueprints, I make a variable for it and make it public because I would like to have access to it later. But let's go to our C++ class and just check what we have here. If you remember, we had the enhance input action that do the movements for us. Also for our hand mesh, we already added a blueprint by hand, but we can also do it in the C++. In order to do this, let's create another class from type actor and call it hand skeletal actor. We will use this instead of the blueprints that we created before. It's from type of actor, but we will add all the hierarchy that we need for our hand. The first thing that we need is skeletal mesh that will represent the mesh for our hand, and also a base object that, as you remember from the previous lectures, we used the create default subobject method to create a base object, and then use setup attachment method to attach it to the root component, and then we will attach also the skeletal mesh to that root component. And when we do that, then we need inside our VR character to spawn an object from this type. We already created hand skeletal mesh actor, and we would like to spawn the object from that type. We have two hands in this case, and we should do the two spawning things. And this spawning will happen by first creating the object of this type by using get word spawn actor from the type that we need. And then if this spawning system is done correctly, then we will cast it to the corresponding type, and we will use it, for example, to attaching to the right component like right hand controller, and then setting the owner of this to the VR character object. We also repeat this procedure for the left hand and we create the left hand and then attach it to the corresponding motion controller. The next things that we need to do, we would like to also save this object somewhere in our class to be able to have access to them later. For example, I call them right hand and left hand here, and I just built the class. When we do this, if we go to our hand skeletal actor and change the class of it to the hand skeletal actor that we created, we will see we have two skeletal mesh because we previously added one in Blueprint and now we have another one from C++. We need to remove the unnecessary one, that is the old one, and keep the new one. And in our VR character now we have the hands. If we go to the play mode, we can see the hands is far away from the character, and it's the problem that we didn't place the position of the hand in the correct place. In order to do this, it's better to define the position of the hand. Either we can define it according to the right or left motion controller and using the transform of that object, or it's maybe easier to have another slots for them that we define and rotate them according to our needs. I created two sample position that here I will use a skeletal mesh component because I would like to use the same shape of the hand as well, and call them right hand placeholder, something like this. Yeah, and then I will do it also for the left hand. Also, as I do not need to access them in the other classes, I can put them in the protected part of our member variables. And then I need to predefine them in the constructor or create them in the constructor to be able to see them. But after that, I can easily access them in my spawn hand skeletal mesh actor method. Yeah, as I mentioned, you can create them in the constructor script. As you probably know, the constructor script is a method that has the same name as our class, but will be run before the game runs, and it can create the objects that we want, or it can do anything that is somehow predefined or constructed by constructing one object of our class. We give it a name and also attach it to the corresponding motion controller. Let me also add some comments here to makes it easier later for us to realize what is happening here and what's the difference between these objects. When you build after that, you can test it in action, but as you can see now, we have two placeholder for the hands that we assign exactly the same skeletal mesh to them. And we can also easily now rotate them and position them in the corresponding place that we would like to see. For example, for the right hand, I think rotating them 90 degrees in the z-axis would be nice, and also rotating them in the x-axis to make it look towards the inside. Like this. We do the same things for the left hand. You just need to first select the correct skeletal mesh asset for it. Great. Now, the other things that I would like to have, as I do not want to see them, these objects in the game mode, I can set them hidden in the game in the C++ class that makes them by default hidden. And if someone else also create another object of this class, this parameter will be set by default and they do not need to modify it. This will be helpful later for the further development. However, as we did some modification in the class, it's better to double check whether the variable variable is already modified like this, and we set it to the default values, our case is hidden in game is active. Always double check when you do some modification in the Blueprint and C++ at the same time to see whether that modification is already happens or not. When we go to the game mode, we can see the hands are in the correct place. However, we can also modify them if you feel it's not exactly in the area that you expect, and it looks very nice. The next point that I would like to test is I want to see whether the animation that we created for the hand is working correctly or not. In order to do that, I assign the animation blueprint that I made for the hand, and then in the VR character class, I have access to that objects as a right hand. However, here is not created yet. We will have it in the game mode. And in order to make sure that it's already created and then doing something with it, we can check the validity of this object. And then we will get the skeletal mesh asset from it. And from the skeletal mesh asset, we can get the animation and cast it to the type that we want, and then setting the parameter of that animation as we expect. Now, by pressing move, you can see the animation is playing as we expected. However, we created this one for the teleport system, but we can also test it with the movement. The other problem that we have is this animation, some of the nanite object that we created is has some offset from our hand. We will figure it out soon. What could be the problem for this offset? If you remember, we imported the hand without any initial pose, but now we defined idle stage in our animation blueprint. We can fix it easily by defining another pose for our hand that is according to the import setting. And then in the gameplay mode, we started with the idle animation. Then accordingly, we can export one default stage or one default animation sequence for it. And then in the animation instance, we will modify that one. However, this animation is the instance is made inside the blueprint, but I would like to have also one C++ class of it to be able to access to some of the parameters in the C++ class. In this case, we create one C++ class inherited from animation instance and give it a name as we expect. For example, it's related to the VR hands animation instance. And then we do not need so much things inside this class. The only things that we need is some parameters that we will make them as a public variable or public members that Blueprint should also have access to it, and Blueprint should see them. We make them edit anywhere and Blueprint read and write and the category of the pose to be able to easily access them. And we call them a pose alpha teleport, similar to what we called before. But we create another variable also and call it is in default pose. We can also make it Boolean, but here I made it just as a float to lerp between them. As you can see now, we have this variable inside our animation instance because we changed the default class of animation instance to that C++ class. And now we can lerp also between the output of the previous condition and the new condition that is in default pose or not. It means when the default pose is 1, we are in the default pose, which is imported pose. And when it's 0, we can lerp between all of the other conditions. And by default, we are in the default pose. Just we need to go to the hand skeletal actor class that we created. And in the begin play method, we need to set the hand animation instance default condition of the is in initial pose to 0. Great. The build might take a little bit of time because we have another class that we created. But now, as you can see, the nanite meshes is in correct place. Now we create another component or another member for our blueprint of the hand from this animation instance to be able to access them. And now if we modify it inside our C++ class, we have the correct animation without any offset. Great, we create our hand with a nice animation and with a system that we can control it. Enjoy your time, and we will see you next time with the next episodes. Bye.